So I suppose that probably it would make sense to start with a sort of general question about what this module is about. So if we say that this is module one, there's some sort of overarching reason why we're talking about module one first, and the thing that module one talks about in the broadest sense is sort of what are the tools that we need to describe motion, right? So we're not actually trying to figure out how motion happens yet. We're not trying to make any predictions about what the behavior is going to be. Obviously, we'll be doing some of that later. We're more at this point interested in introducing the mathematical tools that will help us to describe motion, because those tools are going to make our lives a lot easier a little later when we start to actually try to predict motion and try to do more modeling. So really we're introducing mathematical tools for modeling motion. In general, one thing that we need to do in order to talk about those tools for describing motion is we need to introduce the various sort of kinematic quantities. These are the things that you probably have seen previously in a physics class. Things like position, velocity, acceleration. We also are going to want to be able to describe those quantities mathematically. And so to do that, there are a couple of tools that are going to be necessary. One set of tools are tools around vectors, right? All of these are vector quantities, and so we're going to want to be able to work with vectors. And related to working with vectors, we also are going to have to be able to work with coordinate systems. If we sort of blow out what we mean by working with vectors a little bit, there are a number of things that we want to deal with here. One is sort of what is a vector? One is sort of how do we actually deal with vector operations? So things like adding vectors, doing scalar multiplication of vectors, taking the dot product, taking the cross product, right? What are the various kinds of operations that we do to vectors, and why do we bother doing those operations to vectors? We also are going to be worrying about sort of taking derivatives of vectors and integrating vectors, right? So we're going to want to be able to work with vectors and vector functions in the same way that in calculus you probably previously have worked with scalars and scalar functions, and probably in some cases you've also worked with vector and vector functions before. From a coordinate systems perspective, there are actually a variety of coordinate systems we're going to want to deal with. Some it's likely that you've seen, and some it's not likely you haven't worked with so much. So certainly I expect you've mostly seen Cartesian coordinates before. This is just the good old XY or XYZ type of coordinate system. The sort of idea of the polar coordinate system is probably one that may have encountered before. So here we sort of talk about an angle and a distance from the origin, so for polar coordinates, and we'll extend polar coordinates both to cylindrical coordinates for 3 dimensions and to a certain extent to spherical coordinates for 3 dimensions. And then finally, we're also going to be interested not just in these coordinate systems, but actually in coordinate systems that take their design more from what the system is that you're modeling. So what I will call natural coordinate systems. And in some ways, this is the part of Module 1 that is really pushes you to start to think more about modeling and simulation in this space. I mean, there are obviously a lot of tools that you're dealing with here, but the real question you're dealing with is what are the choices that you're going to make from a modeling perspective in order to describe motion, so that the kinds of abstractions and the kinds of implementations that you exploit later are easier to deal with. So that's sort of an overview of what this module is about. We'll start by doing some of this sort of easier stuff. So we'll start with sort of vectors and some of the sort of simpler operations with vectors. We'll do a little bit of thinking about sort of qualitatively what do these kinematic quantities mean. And then we'll start to work with coordinate systems and also some of this doing calculus with vectors, and end with natural coordinate systems, which I think are both the most powerful idea in this module, but also probably the most challenging idea in the